Let's get started. This took long enough. Good morning. I just woke up, not by my alarm clock, but my alarm clock will go off in 2 days, I guess. But anyway, we made it. A moderator and I, Mark, is also moderating. He was also a bit late. Yeah, so let's get started. Welcome to the presentation by value OpenCV library. Now I have to click to the next slide. Yep. So I'll start with a short introduction, then a little breakdown about by wire, by reference, the difference and why I think it's important. Then my first take on OpenCV, my second take, and my third take. The third take will only be very brief. It's still pending. I'm not sure if it's valuable option. What next? And then last but not least, some demos. So you can see it's still dark here. It's 7 a.m. So I plan to wake up at 4 a.m., but I woke up at 6 a.m. So I'm still a bit adjusting to being awake, but we'll manage. So what is OpenCV? Oh, where's my sheet? Yeah, there. So this started when I had a project that needed to record some video and then resize it, display it, and play back a frame at a certain position. Very simple, but there's not a lot in LabVIEW that can do that. I guess iMac can do that, but this application I had 20 to 60 customers using it, and they don't want to pay a runtime license for each application that they use. So I looked for another solution, and OpenCV sure was able to do that. So OpenCV is an open source computer vision library. It's focused on modern stuff, machine learning, multimedia, filters, stuff like that. But there's a lot in there. It's released under the BSD license. My code is not yet online, but it will be, and it will be open source, probably MIT license. I have to do some cleaning up before I put it online. So how does OpenCV relate to NI Vision? So this is the diagram that keeps popping up in my head. It's completely ungrounded in science, or it's not, I didn't do an objective comparison, but in my head there's a lot of overlap. Basic functions, raster operations, draw functions. But NI Vision, when you look at OpenCV, it's very tempting to say OpenCV has a lot more than iMac, but NI Vision, iMac, still specialized in industrial vision, and tools like caliper tools are just not in OpenCV, or not yet anyway. OpenCV is more focused on modern techniques like tracking, feature extracting, augmented reality, stereo vision. A lot of the modern fun stuff is in there, and if it's not in there, there's a very active community and a very active development picking stuff up. There are stuff in iMac that you will miss, I think, when you work with OpenCV, and that is the interactive Emac control and the overlay, the image overlay. And that's not too hard to make in LabVIEW, but it's not in OpenCV. It's just not a thing that exists in OpenCV. OpenCV, on the other hand, is a lot simpler to work with if you use a library. I hope the demos at the end will prove that. And especially since my version is uses by value. Any questions so far? I don't think so. No, still very late in the night in America, probably deep in the night or in the morning, the rest of the world. So we'll just commence to the next slide. So what do I mean by value? The opposite of by value is by reference, and this applies to by wire. So in LabVIEW, you have two types of data: global data and by wire data. And by wire, you can split up in by value and by reference. And the global you can split up in named and unnamed globals. And there's another type that's weird, and that's IMAC. IMAC wires are just weird. If you ever used IMAC, then you'll notice it's a little bit by value, a little bit by reference, and a little bit named global. I personally find it very unintuitive to work with. So what are the downsides of working by reference? If you work with a reference, you need to create it. It also means you need to destroy it. If you don't, you will have a memory leak. It's not persistent, so when you stop your main, your reference will either stop existing or it will still be there and you won't be able to close it anymore. So you either have no capability to debug your sub VIs when your main stops, or you have a memory leak. And by reference is also, if you work by wire, there's guarantees no race conditions, but the moment you do anything by wire, you will have at least the potential for race conditions. By value, the only downside of by value is that you might get unexpected data copies. If you're careful, you won't, and LabVIEW is very good at avoiding data copies nowadays. So if you don't believe me, this guy, Ristos Q, one of the lead programmers of LabVIEW for a long time, he said that programming with revnums is inherently dangerous because it creates the possibility of the worst class of bugs, race conditions. So race conditions are definitely, they can drive you insane. Well, not everything can be done without a reference. There are things in programming that are referred to. For instance, a file. Files are, well, if you split a file wire, the file reference, what do you expect? You wouldn't expect a second file. So files are intuitively more suitable to be referred to or use a reference. Databases, for instance, anything external really, anything that's not in your programming environment. A camera would also, more to the topic of vision, a camera would be something that you would refer to instead of make by wire. An image, however, why would an image be by a reference? The only reason is that it's a lot of data and you want to avoid copies. But for me, that's not a good reason to make it a reference. So still no questions on the chat? You guys are all a little bit shy, I think, maybe. Feel free to post any questions on the chat. My moderator will relay questions to me. If you don't have any questions, then it will probably be a 40-minute presentation. Okay, you are listening, James. Good to know. Still working on another presentation, maybe. Okay, let's start with the first take that I took on OpenCV. So the first take I took was OpenCV, OpenCV Sharp. OpenCV Sharp is .Net wrapper around OpenCV. It is open source. And .Net is just very convenient for me. It's much simpler than using DLLs. almost in every case. I hardly found any .NET assemblies that were more difficult than the average DLL. In OpenCV, an image is always defined by width versus height. You have the data, and the data is usually a pointer. In OpenCV, you have a lot of types, much more than IMAC. Unsigned, signed, integers, 8 bits, 16 bits. Unsigned 32-bit integers, singles and doubles. And in IMAC, you only have color image and grayscale image. In OpenCV, you can have 1 to 7 color planes. 1 for grayscale, 3 for color. But you can also have an alpha channel, or maybe merge two images in a 6-plane image. You can go wild, but to be honest, a lot of functions expect 1 or 3 planes, so grayscale or color. Another thing to remember in OpenCV is that OpenCV uses GBR, so green, blue, red, and not RGB. But in general, if you stick to OpenCV, then that will go by itself. So the vessel of an image in OpenCV is a MAT. That's short for matrix. I'm not sure why they called it a MAT, but I think maybe it started out as a more mathematical library instead of image manipulation. And in .NET, you can create one like this. So over here, you have the MAT that is created with a number of rows and columns, a type, and a scalar. Type is a bit tricky because type is a bit pattern, but my library handles that, so you don't have to worry about that. And for a lot of functions, the MAT is wrapped in an input-output or input-output array. Again, the library does that for you. No need to worry about it. In .NET, all the templates that are there handle the input-output array, but in LabVIEW, you have to explicitly put it between there. There's also a concept of a submat. So a submat is a structure to a mat, and this basically enables all the functions to act only on a subset, like a region of interest of the image. It's always square though, it's always a rectangle, but it is convenient. So once you have a mat, here I create a mat. Here I call a function. This populates my image with random values. You can get a pointer to that mat, and with I'm working on 64-bit, so I get a 64-bit pointer, and I can move the data to LabVIEW, and this will fill the array, the 8-bit array, with the random data. So this is, I guess, how normally you would do it, and you can certainly make an entire library with this. The problem is, of course, that it's by reference and not by value. So still no questions? Okay. We'll just continue then. Not sure if there are any female listeners on the chat. I didn't see any. Our giants are female, are basically a way to put some attention on the females that are involved in computer science. This one inspired me a lot, not by programming, but she is considered the first female game designer by a lot of people, and she made this little program, River Raid. So I played it a lot, so I guess she inspired me to work with computers. Why is it a problem, Andre asks. So why is working by reference a problem, I guess you mean? Well, the problem with working by reference is that it opens the possibility for race conditions. It also means you have to create the thing that you work with by reference. And it also means you have to close it. And if you don't close it, you have a memory leak. And if it gets destroyed because the main VI, if you close the main VI that opens a file reference, the file reference doesn't exist. So you cannot debug your sub VIs anymore. If you work by value, then that is possible because the values are retained on your front panel. And you can still debug your sub VIs, even though you stop the main. If you, for instance, turn on retain wire values, that doesn't mean anything by reference, because if the VI stopped, then the reference died anyway. So I hope that's, for me, that is enough reasons. Also, if you are familiar with IMAC, it is very unintuitive. And I think mainly that is because you work by reference, or sort of by reference, by named global reference. Yeah, okay. So John, with OpenCV Sharp, you get these problems. I'll show how I worked around it. Because instead of instantiating a mod in OpenCV, you can also create a mod by pointing to data in LabVIEW. So the mod can be created with the data, external data, if you will, by providing a pointer to that data. Now in LabVIEW, you can create data, for instance, with DS functions, data segment functions, I think. That wouldn't really solve the problem because you would still have no control over the data. But you can also get a pointer to an array. I use this function. I think recently I saw a more elegant way, but labview.x has an export function, string ncopy, and if you copy 0 byte, then it will return the offset of your copy, and that will be a pointer to your data. So this is a hacky way to get a pointer to your data, to your array. Of course, if you do it like this, create a pointer here, call the mod here, and then call a function, then LabVIEW might release the data. LabVIEW might have overwritten the data with some other data from another thread. But there is a function in LabVIEW that prevents that, and that's the emplacement structure. So the emplacement structure is a way to tell LabVIEW that this data that is read here will be written here again, so that it won't release the data. It will keep the same pointer usually. I never had a situation where it doesn't. And by using this, I can get a pointer to native data in LabVIEW, either a class or a cluster, and initiate a mod to the data. So this means that this function actually manipulates the data that is native living in LabVIEW. There's one problem though. LabVIEW keeps track of the data, and if you don't mark it as modified, then LabVIEW will consider the data clean. And if you have a VI that creates an array, and you don't mark as modified, then LabVIEW won't initialize the data again. So if you initialize an array with zeros and you add 1 in the DLL and you run it 5 times, the data will be 5 instead of 1. So that's one situation where the mark as modified has a use case. I don't think I had another situation where it is useful, but it certainly does something. So with OpenCV, I started making functions, image read write. some drawing functions. You can do the usual stuff, circles, lines, markers. Some fancy stuff, fancy filtering. Over here you can see the pencil sketch filter, for instance. That's typically something that is in OpenCV and will never be in iMac because it's multimedia related and not industrial. So some more functions, even more functions. And then I found a nasty bug. I'm not sure if the bug is in LabVIEW or in OpenCV or in .Net, but it turns out that once I created a few mods and I call any function in a continuous run and then call the function 4 times, then LabVIEW would crash. So that's basically to me meant that the entire library was unusable. So I started. Any questions so far? Still no questions. You guys are either you are. I am completely clear, or nobody's listening. Let me get some tea. Okay, I'll continue. So my second take, I found out that OpenCV Sharp uses an external library, and this library seemed very close to OpenCV functions, the native OpenCV functions. And it turns out that the OpenCV Sharp functions basically are wraps around the OpenCV Sharp external DLL. The only problem is that the DLL functions throw exceptions, and LabVIEW considers this a crash. So LabVIEW will say this DLL crash LabVIEW, and you have a corrupted memory. You would need to restart LabVIEW. That's really not the case. It's just the DLL throwing an exception, and .Net can catch that exception and turns it into a nice string for the user, and the DLL doesn't. So just to compare, this is a full-blown function with .Net, with all the boilerplating. Over here is the function. Here's my my VI that returns a DLL. Here I turn it into a mod. And here basically I do the same with the second image. So I have two mods, one that calls the function and one that acts as a mask. And with the DLL, this looks like this. It actually got a little bit simpler in this case. It doesn't always get simpler. So the difference between the two wasn't that hard. Of course, if you have to convert 80 functions, that's a bit of a pain, but it was manageable. Some functions, however, were very difficult. This one takes all kinds of non-typical functions or objects, object points, image points. No other function in OpenCV uses them. So how did I manage to convert this to the DLL function? This is the full-blown example. This is not in the library, but it's a test. So it takes, as it turns out, an array of points. So this took a little bit of debugging that I used to find out how to do it with the DLL. So what I used is DNSpy. I can show you that live. So DNSpy is a .NET debugging application, and you can use it to open us any .NET application. You can even, if it's an executable, you can even run it and debug it. But in OpenCV, it's a DLL, so you can look at all the functions that are in there. All the bulk is in CV2. And my calibration function should be somewhere here. Calibrate camera over there. And .NET is very self-documenting. There's a lot of runtime information. So this also means that a disassembly can basically turns it back into readable .NET, C# code in this case. And over here we can see that it calls the DLL. Oh, this is not readable. No, I don't think I can make it bigger. I hope at least the concept is clear. This is .NET code, C# code, and you can see where it goes to the function. And over here you get the DLL function protocol that you can use. So this gives a lot of information. You can actually see the compiled .NET code, and you can see the raw DLL that is used by .NET. You can analyze this function, and then you can see that it's used by the .NET function, so you can go back and forth. So this is very nifty tool that you can use to debug assemblies. So another tool I used is a debugger. So how I do that is I open LabVIEW in a debugger and then load my project. I can find the OpenCV library and put a breakpoint on the function. Once there is a breakpoint on the function, I can call the .NET function, and I can see the stack that is used to call the function. Once I have the stack that .NET uses, I can examine it and study it and try to replicate it in a raw DLL call. So I guess this will be too small to demo. It helps if you are proficient in assembly, of course, which I am. And then it's useful, but nowadays I'm not sure if it's worth studying. But if you have that knowledge, then it's very useful. So here's the resulting DLL call. I don't think I would have guessed this. So I have an array with arrays of points, and then the DLL expects an array of pointers to the subarrays in the array. Oh well, it works, so we can now use the calibrate function in OpenCV. Here's the full version. There's some boilerplate code here to get the data. Some ducks passing by. They're gone, so it's quiet again. So any questions? Still no questions. If you guys don't have, well, we have one question, so that's encouraging. No questions? Okay. Let's continue. The third take. The third take is still pending because I figured, why would I use the external DLL and not use the raw OpenCV DLL? So this was I tried it at first, but turns out the worst thing with this DLL is that it uses mangled function names. So when you compile a DLL with C++, then you get the function protocol in the function name, and that is because a function can have multiple calls with multiple classes. So this mangled function names are the way that the compiler makes sure that that you call the function names with the correct parameters. The only problem is that the function names have a lot of strings and hashes in the function name, and LabVIEW filters them out. So you cannot select them in LabVIEW. You can, however, copy paste the function name in LabVIEW. I have a question. I can do it in between. Did you ever try OpenCV MGU version? I did look at it. The problem I had with OpenCV MGU was that once I downloaded it, it wasn't complete. The OpenCV DLLs itself were not included, I think. So at the time, I had no clue about OpenCV or how it worked. So I skipped and jumped to OpenCV Sharp. So I didn't. I don't know if it will crash under the same circumstances. I do know the problem, because the problem is that when there are no functions left, no .NET functions left anymore. So all the .NET references are released. The DLL that is used by the .NET is released from memory, and if there is still memory created by the DLL, then that crashes. So I think the situation is that the DLL is released while the .NET still depends on the external code that is allocated by the DLL, and that crashes LabVIEW. So Andre, you also had crashes when searching LabVIEW code? Okay. I assume you mean that LabVIEW crashes if you have.
I can comment. So if
I think you muted.
If such a name comes to DLL,
well,
and after that you simply Control F and search for some string, there is very high probability that LabVIEW crashes. Why? I don't know.